Hello, I'm Logic Bunny, and come with me down the rabbit hole of knowledge.
Ever wondered why your grandma always throws salt in the pasta water? Does it really make the water boil faster? What if I told you that what you think you know might be wrong? I'm Logic Bunny, and today we're diving headfirst into the amazing world of kitchen chemistry. That's right, your kitchen, that place filled with delicious smells and late-night snacks, is actually a secret science lab just waiting to be explored. You see, cooking isn't just about following recipes. It's a series of incredible chemical reactions happening right before your eyes, and understanding these reactions, well, that makes you a better cook, a more curious person, and a total kitchen wizard. So, does salt speed up the boiling process? That's the million-dollar question. Let's put this common belief to the test. We're going to conduct a real experiment, just like the brilliant scientists we all admire. We'll take 2 pots of water, one with salt, one without. We'll measure everything carefully, timing the boil, observing, and taking notes, just like Ibarra the Norio himself. This isn't just about boiling water, it's about learning how to think like a scientist, asking those awesome why questions, and discovering the truth behind the things we take for granted. Are you ready to have your mind blown? Prepare to uncover the secrets of the boil? Let's dive in and find out if Grandma was right all along. Let's dive into the science of boiling. Ever wondered why you add salt to your pasta water? Well, the answer might surprise you. Salt does affect the boiling point of water, but not in the way you might think. It actually slightly increases it, but here's the thing. That increase is so tiny, so minuscule, that you wouldn't even notice it when you're cooking. So let's get our experiment set up. We'll need 2 pots. Fill them with the same amount of water. In one pot, we'll add a generous amount of salt. In the other, nothing but pure, plain water. We'll use a thermometer to measure the temperature of the water precisely. Now, what is boiling anyway? Think of water molecules as tiny dancers. When you heat the water, you give them energy, making them move faster and faster. Boiling happens when these dancers get so energetic that they break free and escape into the air as steam. Salt slightly raises the temperature these dancers need to reach to escape. It also slows down the overall heating process because the salt needs to dissolve. So, what did our experiment show? The water with salt might have boiled a little slower, or maybe, just maybe, it boiled at about the same speed. The perceived speed comes from other factors, like how hot your stove is, or the material of the pot. So, the next time someone tells you salt makes water boil faster ... you'll know the real secret. Alright, so we've busted the boiling myth. But the story of salt and kitchen chemistry doesn't end there. Let's explore the exciting world beyond boiling. Salt isn't just about making water boil. It's a master of flavor, texture, and even food preservation. Think about it. Why do we pickle cucumbers or cure meats? Salt plays a huge role. Let's talk taste. Salt enhances flavors. It interacts with the taste receptors on your tongue, those tiny detectors that tell your brain what you're eating. Salt is like a key that unlocks the flavor. Other ingredients, like sugar and acids, also play their part in creating those amazing flavors we love. Now, let's talk texture. Salt affects the proteins in food. It can make meat more tender. It helps dough rise, creating fluffy bread. Acids, like vinegar or lemon juice, also have their secrets. They help tenderize food, and they add amazing flavors. So, what can you do with all this knowledge? Well, I challenge you to try your own kitchen experiments. Why not try making your own pickles? Or whip up a simple marinade. The kitchen is your lab. The possibilities are endless. Stay curious and keep exploring. Alright, are you ready for another kitchen adventure? Let's tackle a classic, the hard-boiled egg. Ever struggled to get it just right? Undercooked, overcooked, impossible to peel. The perfect hard-boiled egg can be a real challenge, but don't worry. We're about to crack the code. Here's how to do it. Gently place your eggs in a pot. Cover them with cold water. Bring the water to a rolling boil. Once boiling, turn off the heat. Cover the pot and let the eggs sit for about 10 to 12 minutes. Then transfer them to an ice bath. Now, what's the science behind it all? When you heat an egg, you're changing the proteins. These proteins, which are all tangled up, start to unwind and connect with each other, creating a solid structure. That's what makes the egg firm. But what about those common problems? Green yolks. That means you overcooked them. Eggs that are hard to peel? Older eggs peel easier. So, there you have it. The perfect hard-boiled egg explained with a little bit of kitchen chemistry. And the bigger picture. Understanding how cooking works makes you a better cook. It sparks curiosity. It encourages you to ask why. So, go on. Experiment. Become a kitchen scientist. Ready to bust some cooking myths. You know, those things we all hear. The advice passed down from generation to generation. Well, some of them are true, and some of them aren't. Let's dive into some common cooking misconceptions and uncover the science behind them. Myth number 1. Adding oil to pasta water prevents the pasta from sticking? Does it really work? Not exactly. The real reason pasta sticks is because of the starch released from the pasta. Myth number 2. Searing meat seals in the juices. Think about those delicious browned edges on a steak. That's the Maillard reaction at work. It creates amazing flavors, but it doesn't actually seal in the juices. Myth number 3. You need to let meat come to room temperature before cooking. While this is often recommended, it's not always necessary. The key is even cooking. So, what have we learned? Well, we've learned that not everything you hear about cooking is set in stone. The most important thing is to be curious. Question everything. Test it out. Experiment in your kitchen lab. That's the fun of it all. So, go forth and keep those taste buds and your mind busy. So, where does all this kitchen chemistry stuff leave us? Well, it leaves us with a secret weapon. Understanding the science behind cooking is your key to culinary adventures. It's how you become a better cook and how you start to understand the world around you. But it doesn't stop in the kitchen. Think about it. Chemistry is everywhere. From cleaning your house to growing a garden, the same scientific principles apply. So, keep experimenting, keep exploring, keep asking why. What kitchen mysteries will you unravel? What delicious discoveries will you make? Share your own kitchen experiments in the comments. I can't wait to hear about them. And hey, suggest some future topics. What else would you like to explore? Remember, the most important ingredient is curiosity. So, keep experimenting and keep cooking. So, what have we uncovered today? We've busted a myth about salt and boiling water. We've explored the amazing world of kitchen chemistry, and we've learned that cooking is so much more than just following recipes. It's science. Remember, salt asterisk slightly asterisk increases the boiling point, but it doesn't make water boil faster in any meaningful way. We've seen how chemistry affects flavor, texture, and even how to cook the perfect egg. The kitchen is your laboratory. Every meal is an experiment, and the best part, you can apply these principles everywhere, from the kitchen to the classroom to your everyday life. Want to learn more? Check out the links below. There are tons of amazing resources out there. But remember, the most important tool is your curiosity. Learning is a journey, not a destination. Every experiment is a step forward. So, embrace your inner scientist. Keep exploring, keep questioning, and most importantly, keep cooking.